Number 26, write each equation in vertex form, or write this in vertex form. So one way of writing it in vertex form is completing the square. I don't even recommend that. I recommend you just find the vertex, okay? Because a vertex form equation is y equals a parentheses x minus h squared plus k. So if you know your a value, if you know your a value, your h value, and your k value, you'll be able to write your equation in vertex form. So let's focus in on finding the vertex. Now the vertex you could find by doing x equals negative b over 2a. And let's zoom in and focus in on this vertex. Remember, the vertex is really a coordinate, x and y value. And the x value is found with this formula right here, x equals negative b over 2a. So we have negative b over 2 times a. That's negative 16 in the parentheses over 2 times 2. So that's a negative 16 over 4, which means that your x value is what? Negative 4. So your x value is negative 4. Now we need to find our y value. How do you do that? You simply plug it back into your x values. So I'm going to rewrite this entire equation, but without the x's, I'm going to put parentheses instead. So we're going to plug in the negative 4 into the parentheses. And working on exponents first, that's 16. And then 16 times 2, that's 32. And then 16 times negative 4, that is a negative 64. And then plus 29. So you really have negative 32 right here, plus 29, which is, what is that? Negative 3? So your y value is negative 3. So ladies and gentlemen, we have found our vertex, which is really an xy value, which is really an h and k value, okay? So you know your h value is negative 4, your k value is negative 3. And knowing the negative 4 and negative 3 for h and k, you already know that it's going to be x minus h. So you have minus, but what's your h value? It's negative 4, parentheses squared, plus k. Your k value happens to be a minus a minus 3, I'm sorry. And of course you have your equal sign over here, your y. Now we still need our a value, okay? So if we still need our a value, this is going to be our answer right here, but we still need our a value. So where is the a value? It's simply the a value on your standard form equation, which is 2. So ladies and gentlemen, we are done. And thank you, Juliana. We're also going to rewrite this the best way we can, which is y equals 2, parentheses x plus 4, because the minus changes to plus. And that plus negative 3, you might as well write it as a minus 3. That's the best answer. That's what you're actually going to find on the multiple choice on your final. Jumping to 27A, solve the systems, okay? So this is a 2x2 system. It's not that crazy. You might think it's crazy because of the fractions, right? So how about this? If you don't like the fractions, let's get rid of fractions. You could get rid of one fraction at a time by multiplying by 4, or you could get rid of all of them at the time by multiplying by your LCD. What's your LCD going to be? 8. So if we multiply all of the bottom equation terms by 8, it'll get rid of all fractions at once. The 8's completely cancel. You're just going to have a 7 left over right here. Now the 8 over 2 cancels out. You have a 4 left over, and 4 times 1 is 4 with the y. And of course you bring down that minus sign. And again, 8 divided by 4, that's 2 over here. And 2 times 1 is 2, and of course with an x. So here's our new equation. So I'm going to rewrite the top equation right here. It's 2x minus 4 equals 7. And I want to rewrite this new equation without fractions right there. It's 2x minus 4y, oh I forgot the y on the top one, equals 7 also. So guess what, guys? This is your 2x2 system that you need to solve, but it's the same exact equation. So if they're the same exact equation and you try to cancel something out, you're going to multiply the bottom one by negative 1. It's going to change all the signs, which means that when you combine them, that cancels, this cancels, that cancels, you get 0 equals 0. Is that a true or false statement? That's true. That's always true. So the answer to this system is infinitely many solutions. Infinitely many solutions. Now, on the other hand, if I would have been working this out and you end up with something impossible, it would be no solution. I think that's the kind of example I put over here. Over here, what would I multiply the whole top equation by? 6. And this will cancel, you have a 3 left over. And this will cancel, you have a 1y left over. This will cancel, you have a 2 left over. And all we need to do is multiply what's left over with the numerators. So on the top, you're going to get 3x. On the top, you're going to get 1y. And you're also going to get 4. And if you notice, the bottom one has a 3x, also plus 1y, but it equals 6. Yes? So, in order for us to combine these guys, you're going to have to multiply one of the equations by -1 to get something to cancel. So if you multiply the bottom equation by -1, you have a -3, a -1y, and a -6. Cancels, cancels. You end up with 0 equals -2. That's an impossibility. That's where you say no, as in no solution. Or you could do that symbol right there. You got it? All right. Final question on this godforsaken, long, hideous practice test. 28a. Given that quadratic trinomial, which of the following is a factor? Which of the following is a factor? Okay, so you need to factor this, right? Or of course you could guess at it, but you need to factor this. Now, you can't divide everything by 6, or you can't divide it by 3 or by 2. So you're kind of stuck right here. You could use that long method of multiplying a times c. Or what I would do is do the quadratic formula. It's going to be kind of long, but you could use the quadratic formula. Now remember, the quadratic formula is only for solving equations, so it's kind of like I'm pretending that it says equals 0. That way I could actually plug in my b value of 7, my a value of 6, my c value of -20, my a value of 6. So when I work on this thing, I have a -7 plus or minus the square root of 49 plus, because a negative times a negative is a positive, 24 times 20 on a calculator is 480 divided by 12. Now if I go 49 plus 480, I get 529, and if I take the square root of 529, I'll get 23. Okay, so once again, I get -7 plus or minus the square root of 529 over 12, and the square root of 529, if you do it on a calculator, is 23. Okay, so I'm going to have -7 plus or minus 23 over 12, which this actually gives us two answers. It gives us -7 plus 23 over 12, and also -7 minus 23 over 12. So when you go -7 plus 23, you're going to get 16 over 12. And that answer could reduce at least down to 8 over 6, 4 over 3. So there's one answer if it were an equation. And the other one would be -30 over 12, which reduces down to -15 over 6. And then that reduces down to, if you reduce it by 3, it reduces down to -5 over 2. So those are our two answers if it were an equation. So what does that mean, that those are our two answers if it were an equation? Now I'm going to work backwards like if I were factoring, all right? Of course, you could always factor the long way, but if I had x equals 4/3 and x equals -5 halves, then if I wanted it to be a binomial set equal to 0 and a binomial set equal to 0, then I would have to get rid of that 3 by multiplying by 3 and multiplying by 3. That way I could get a 3x in here. Then I'd have to subtract 4 to get it set equal to 0, so it'd be a -4 right there. Is everybody comfortable with that? I hope.
Yeah.
On this other one, I'm going to multiply by 2 to get a 2x in there. And then I'd have to add 5 to both sides to get a plus 5 in there. And now I'm going to put them together as... So ladies and gentlemen, what we did was worked backwards. So instead of having your original factoring and then splitting and solving, I did the quadratic formula to get my answers to work backwards to get my factored form. So both of these are our factors. The question is, which one of those is a factor on the multiple choice answers? It is D, the 3x minus 4. Does that make sense? It's right here. The 3x minus 4 is one of the factors.